Okay, so just a few comments on the previous video. That for indistinguishable to distinguishable, the general formula is n plus r minus 1 choose r. So that's exactly what we did. We have 10 ones and 4 variables that are distinguishable, and then we're choosing this for dividers, or r minus 1. We're choosing these 3 dividers. But like, you don't need to memorize this formula as long as you understand the divider and both concepts should be divided. You can derive it by yourself. It's not, it only takes like 5 seconds. All right, so the third topic is distinguishable to indistinguishable. So here is where the starting numbers come. So basically, there's no easy way to do this problem, but like we can use the starting formula. The starting formula is basically just an easier way for us to order our counting. So the definition of starting NG means that the number of ways to distribute n distinguishable balls into G indistinguishable balls such that no box is empty. So the idea is, for example, as for 1 means means distributing 4 different objects. Let's say A, B, C, D into 1 indistinguishable box, and there's only one way to solve that, is to put them all in that box. So that's just one way to solve this problem. I guess as for 1 is equal 1, and as for 2, it basically means we need to distribute A, B, C, D into 2 distinguishable boxes that no boxes are empty. So we can do that by 2 in 2, 2 in 1, and 2 in 1, or 3 in 1 and 1 in 1. So the 3 and 1 here are the balls, and 1 and 1 here are the indistinguishable box. So the way we do that is we can also count it out. So 2 in 1, 2 in 1, that means either AB in one office and CD in one office, or AC in one office, CD in one office, or AD in one office and BC in one office. So there's only actually 3 scenarios. So easier way to count this out is 4 choose 2. 4 choose 2 will give you the 2 thing, but we need to divide it by 2. So for example, 4 choose 2 from A, B, C, D, we choose A and B. So the remaining has to be C and D. However, if we choose CD, the remaining has to be A, B. So we actually count each scenario twice. So we need to divide it by 2. It also gives you the same answer. And for 3 in 1, we can put A, B, C in 1 and D in 1, or A, C, D in 1 and B in 1, or A, B, D, and C in the other one, or B, C, D, and A. So there's 4 ways to solve that. So the idea is basically just get rid of one person in that one office or in that one box. So there's 4 ways to get rid of one person. So in total, as for 2 equal to 3 plus 4 is equal to And then let's look at as 4, 3. That's basically putting 4 people into 3 different boxes. Since we only have 4 people, so it has to be like 2 in 1, 1 in 1, and 1 in 1. So essentially, if you copy it out, it should be 4 choose 2, because the only 2 in 1 that's different from the other, it should be 6. But we can count it out. We can choose A, B, and let C and D on their own. And we can choose A, C, and let B, D on their own. We can choose A, D, and let B, C on their own. And we can choose B, C, and let A, D on their own. We can choose B, D, and let A, C on their own. And we can choose C, D, and let A, B on their own. So in total, we have 6 ways. So as for 3 equal to 6. So now let me ask you a question. How many spaces are there to put 4 different employees A, B, C, D into 3 identical office? I'm allowing empty person. So if I don't allow the empty room, if I don't allow empty room, that's directly as for 3, because that's basically exactly what as for 3 are talking about. But now I'm allowing the empty room, so we just need to challenge this condition. We need to get rid of this restriction. So how do we get rid of this restriction? We translate this problem into a different problem. So now let's say this is one scenario where I have 0 empty room, and then I can have 1 empty room. So if I have 1 empty room, that means only have 2 rooms left for 4 people. So that's as for 2, which is 7. We just calculate out, and then I can allow 2 empty rooms. So that's just as for 1, because we only have 1 room left. So that's 1. If we allow all 3 empty rooms, the problem doesn't work, because we need to arrange these 4 people into 1 of the room. So in total, this problem is just 6 plus 7 plus 1 equal to 14. I mean, you can also write it in the crazy summation form. So J equal to 1 K as NG. So in this case, it's from J equal to 1 to 3 as 4G. So that's just as 4, 3 plus as 4, 2 plus as 4, 1. If you completely forget what starting formula is, you can count it out, just like what I did before I mentioned this formula. If you really want to know the starting formula, and it might appear on your multiple choice and true or false problem, go back to the lecture note and review that and make sure you can correspond the starting formula and the counting part we did before. Yeah, I mean, video is posted online, so you can always look at it if you didn't understand. All right, that's it.